Hi, in this video we're going to learn how to solve a projectile motion problem. Now there are a bunch of different types of projectile motion problems that you can try to solve. The one that we're going to focus on today has a projectile that starts out with a horizontal velocity. Okay, a horizontal velocity. So the problem is that there is some airplane that is traveling at a certain speed with a cargo that it plans to drop. Okay, so we have our airplane and it is traveling forwards, and it's traveling forwards at 30 meters per second, and it is 1.5 kilometers above the ground. So we know that our initial horizontal velocity, our Vx, we'll go ahead and write that down, is equal to 30 meters per second. And then we also know that our delta y, the distance that it will drop to the ground, is 1.5 kilometers, or we'll go ahead and write that in meters. It's 1,500 meters. So it's going to drop some object. This object is going to operate as a projectile. It's not going to fall straight down because it's got some velocity to the side. It's going to follow a projectile path like so. This will be our ground there. So the question is, the first question that we can ask is, what is the total time that this object falls for? What is the time? And the way that we're going to answer that question is by realizing that the amount of time this object falls is how long it takes it to go from here to here in the vertical direction. In other words, how long it takes us to achieve our full delta y. So there's a couple of other things before we get started with that. There's a couple of other things about this problem that we know. We know that this object is being accelerated downwards, and it is being accelerated downwards by gravity, which is always equal to negative 9.8 meters per second squared on Earth, right? Is there anything else that we know? We know that it has an initial vertical velocity of VIY of 0, because this plane is traveling horizontally, so all of this object's velocity is in the side-to-side direction rather than the up and down direction. It has no up and down velocity, no initial vertical velocity. Is there anything else that we need to, or that we know right now? No. So the next thing that we'll do is select an equation. The equation that we will need to use for this is that delta y equals VIY times time plus GT squared over 2. We see very quickly that our VIY is 0, and so this whole term will be 0. When we multiply by time, it doesn't matter what time is, it'll wind up being 0. So we can simplify this to delta y equals GT squared over 2. Now at this point, we've picked our equation. We can solve it for our unknown. Our unknown is time. So let's go ahead and rearrange it. And we'll start out by multiplying both sides by 2. Our 2's cancel on the right. And so then we have, I'll just come over here to the side with this for space's sake. We have 2 delta y equals gt squared. Next we'll divide both sides by g. And so our g's on the right hand cancel out, and we are left with 2 delta y over g equals t squared. Now, you're not done. we need to go ahead and take the square root of both sides, because this is solved for t squared, not t. So take the square root of this, our squared and the square roots cancel, take the square root of this, and what we finally end up with back over here is the square root of 2 delta y over g is equal to t. So that's the formula that we'll use. We can go ahead and plug in our numbers to find what t is. Let's go ahead and do that. The square root of 2 is a constant. Our delta y we said was 1500 meters, so 2 times 1500 meters divided by our gravity. And actually, here's a good point. A lot of times we'll tend to write this delta y in terms of a positive value, but it is a displacement vector. And if you'll notice, this object is moving which direction? It's moving down. So our delta y is not actually positive. It is in fact a negative number, because the negative sign indicates that it is a displacement in the down direction. So we need to be careful of that, otherwise this will not make an awful lot of sense. And then for gravity we have negative 9.8 meters per second squared, and that is equal to time. So we can just throw that into our calculator. We'll just do it all in one go. We should be able to plug this into a calculator at this point. So let's see if we can see this. Our square root of, what was it? Quantity 2 times negative 1500 divided by, close that parenthesis out, nope, don't close it out, divided by negative 9.8 should give us our answer. Yes, 17.4964. So 17.4964. Notice that our units will be seconds, our meters will cancel, and then the square root with our seconds squared will cancel. So we wind up with t equals 17.4, call it 0.50. 17.50 seconds is our time. Alright, so that's one thing that we've gotten out of the way, but in this particular question that we're looking at, there's a little bit more to it. It also then asks us to find our final velocity. Okay, so we'll just draw us a little line here. Okay, find our final velocity. Alright, so this is a continuation of that same problem, and if we wanted to find our final velocity, we have all this information that we've already established to this point. Our final velocity, we'll need a formula then. We have our knowns up here already, and we know time now is equal to 17.50 seconds. So is there some way that we can find our final velocity? Well, our final velocity is going to have two components, and we'll just sketch a quick picture here. This box is going to go down and hit like this, so it's going to have some horizontal velocity and some vertical velocity in the down direction, right? Let's see if we can see that. Yeah, we can see that there. So we'll have those two components to our final velocity. The question is, what are these two components individually? And then after we know that, we can just add them up like we would any other vectors. So, for starters, we know that our horizontal velocity is 30 meters per second, and there's no horizontal acceleration in a projectile motion problem. So, this is our final horizontal velocity. That's our horizontal component there, 30 meters per second. The question is, what is our final vertical velocity? Well, to find that, we need to use the formula Vf equals Vi plus AT. Do we know what Vi is? Yeah, it's 0. Do we know what acceleration is? It's negative 9.8 meters per second squared down. And do we know what time is? Time, we calculated earlier, is 17.5 seconds. So can we find the final y velocity? You betcha. We'll go ahead and plug in a few numbers here. We'll do this math mostly on this page, and then we'll wind up going to a new page here pretty soon. Vfy equals negative 9.8 meters per second squared times 17.50 seconds. And if we throw that into a calculator, we get negative 9.8 times 17.50 gives us negative 171.5. So we can just write up here. Normally I'd write this down below, but so that you can see it on this page. Vfy equals negative 171.5 meters per second, because our seconds squared and our seconds here cancel out. Okay. So that is our final velocity in the y direction. Now, to solve it the rest of the way, you just add these two vectors up and get a total vector here with the Pythagorean theorem, and then use the inverse tangent to find the angle with the horizontal, which I've drawn it on the vertical there, but you would find the horizontal angle, this angle here, not that one. Okay, so that should be pretty simple. That really sums up this problem, so thanks for watching. There will be another video as well on projectile motion where the initial vertical velocity is not 0. I also have other videos on how to add vectors if this last step was not something that you were clear on. Go back and watch those videos to clear that up. So thanks.